Kilobyte. I would take kilobyte more seriously if it didn't sound so much like kibbles and bits. Title text: I would take kilobyte more seriously if it didn't sound so much like kibbles and bits. Explanation: this comic pokes fun at the confusion over the definition of a kilobyte. Historically, 1024 bytes was called a kilobyte for convenience purposes, same with megabyte and gigabyte. This usage was frowned upon by both the International Bureau of Weights and Measures and the Institute of Electrical and Electronics Engineers, but both let it slide as they had more important things to deal with. Later, hard drive manufacturers realized they could save money by selling hard drives marketed X amount of gigabytes and declare that they meant it as a literal 1 billion bytes, a 7% difference. Despite its iffy origins, the official definition now states that 1 kilobyte is 1000 bytes, however some continue to use the older meaning referring to 1024. The first row of the table is simply mocking this discrepancy. The second row is Randall's interpretation on how Stan Kilobyte would approach this problem. Kilobyte is known for writing the Computer Contradictionary, which satirizes the jargon and language of the computer industry. Kilobyte was likely motivated to write this work after working for several years at IBM, a company infamous for its excessive use of acronyms in the workplace. Averaging the two definitions together to get 1012 bytes is simply a humorous approach that Kilobyte would likely have taken should array indices start at 0 or 1. My compromise of 0.5 was rejected without, I thought, proper consideration. Stan Kilobyte. The serendipitous fact that the initials of Kilobyte's name are KB, the same letters used to abbreviate the word kilobyte, adds a layer of plausibility to the joke. This is the first of Randall's many humorous compromises. The imaginary kilobyte simply plays on the fact that complex analysis is required in quantum computing in relation to quantum mechanics. The imaginary number is represented as I and has a value of the square root of -1. This is a pun on the fact that KB is used for the binary kilobyte, occasionally kilobyte, which is standardized at 1024 bytes. The Intel Kilobyte mocks the Pentium floating point unit that, in 1994, became notorious for having a major flaw in its floating point division algorithm that gave slightly erroneous results. The smaller, DriveMaker's Kilobyte mocks a business model for handling higher prices that keeps prices constant but reduces quantity, also known as shrinkflation. The food industry has been notorious for decreasing quantity of food and keeping prices the same instead of increasing prices and keeping quantity the same. Randall is suggesting that if the computer industry tried to do this with hard drives, it could have humorous results such as smaller number of bytes in a kilobyte. This discrepancy increases with increasing drive size. The trend humorously suggested in the comic, however, would make the DriveMaker's Kilobyte 1024 bytes in 1979, 1000 bytes in 1985, 836 bytes in 2026, and 0 bytes by 2235. The baker's kilobyte is a play on the baker's dozen, which is 13 instead of 12. A baker's byte with 9 bits to the byte would result in a total of 9,216 bits in a 1024-byte kilobyte. Converting this into normal bytes with 8 bits, we divide 9,216 bits by 8 bits per byte to get 1,152 8-bit bytes to the baker's kilobyte. In the title text, Randall mentions the definition kilobyte, which is defined more precisely. The binary prefix kibi means 1024, a portmanteau of the words kilo and binary. But he doesn't like the word because it sounds like the dog food kibbles and bits. Transcript. There's been a lot of confusion over 1024 vs 1000, kbyte vs kbit, and the capitalization for each. Here, at last, is a single, definitive standard, Table of various kinds of kilobytes. Symbol. Name. Size. Notes. KB. Kilobyte. 1024 bytes or 1000 bytes. 1000 bytes during leap years, 1024 otherwise. KB. Kilobyte standard unit. 1012 bytes. Compromise between 1000 and 1024 bytes. KB. Imaginary kilobyte. 1024 square root dash 1 bytes. Used in quantum computing. KB. Intel kilobyte. 1023.9375528 bytes. Calculated on Pentium FPU KB. Drive makers kilobyte. Currently 908 bytes. Shrinks by 4 bytes each year for marketing reasons. KBA. Baker's kilobyte. 1152 bytes. 9 bits to the byte since you're such a good customer. Discussion. The drive maker's version here does depreciate their kilobyte, indeed, but rather than based on slipping food standards which are often highly regulated, I think this is actually based upon the actual age-old practice of them sometimes using 103 and 1000s, 1 millions, etc. measures of byte multiplies in preference to 210 and 1's 1024, 1,048,576, etc. in order to get a better figure. For example, 20 megabytes drives back in the old days, this is with 971,520 bytes, almost 1 MB, by either measure less than the true binary matching 20 MB value which various computer OSes would work with. Or a binarily 20 megabytes drive gets advertised as 20.1 megabytes 1. On the other hand, something that needs 20 MB of installation space might have deliberately been given the binary divisible version of the unit to make it look marginally less resource hungry than the decimalist measure would have indicated. Minor differences in their own right. On a bad day when the competing standards mesh badly, you might find yourself just short of storage space when you thought you'd be okay. Although in real life the difference between any given unit's interpretation has not changed, as equipment capacities increases and we start to use increasing degrees of prefix upwards, any discrepancy becomes more significant. 1 KB is plus or minus 24 bytes 2%, 1 megabyte is plus or minus around 48 KB 5%, 1 GB is plus or minus 73 megabytes 7%, and 1 TB could be very nearly 100 GB short 10%. For those that care about these things, that's at the very least annoying. Like with CRT monitor sizes that were often more an indicator of tube end size than the true size of the visible illuminatable portion, giving them an inch or two less of effective display than you might expect. 178.98.31.27 1355, June 18, 2013 UTC. Just to follow up to myself, based upon a unit capitalization discrepancy that I only spotted post-posting, but that I won't bother fixing, there's also the old confusion between kilobits per second and kilobytes per second and mega and giga versions, more recently with broadband and more advanced Ethernets etc. when it comes to bandwidths and expected speeds. Although you don't necessarily expect to exactly hit the stated limit with contentions and collisions and latencies and overheads, getting a factor of 8 less than you might have expected has caught people out before, thinking they're getting a far poorer service than advertised. Not that this has much to do with the above comic, just saying. And, oh looky here on my desk. A 28800 Sportster PCMCIA fax modem card V34, V32 bis with an SJAC registered pop-out socket. Why have I still got that 178.98.31.271416, June 18, 2013 UTC? This table fails to mention, of course, that while a baker's kilobyte is 1152 bytes normally, it's 1125 on leap years. Babylon 1 Talk 2321, October 26, 2017 UTC. Apparently, the N64 has 4.5 MB of RAM. Learned this from a Kaze Imanur video recently. I'm at work, so can't look up the video now, otherwise I'd link it. 172.70.47.112/1204, January 6, 2025 UTC. What is the source of the official definition of the kilobyte from the article at time of creating this topic? The official definition now states that 1 kilobyte is 1000 bytes. This is official according to whom exactly. I may have missed a citation somewhere, but I think this clause needs a citation in the text of the article. Azure Armageddon 1350, October 3, 2023 UTC. Well, SINIEC either state or recommend that a kilobyte KB is 10 superscript 3 bytes, while tradition has tended to use KB capital K for 2 superscript 1 bytes, obviously open for confusion, while IEC defines this as a kilobyte KB. There's several possible sites for that. One really would need to decide which look best official. As a general hint to people, though, I think that makes it probably best to just always use explicit KBS, and MB TB etc. equivalents, in full or as unit abbreviations, because there might be people who haven't got the memo, don't know whether you got the memo, otherwise. And at least there's a chance that even those unaware of FOOBabytes will try to find out what these are, unless they just mistake them for typos or read them unconsciously wrongly, but then there's probably more problems than just assuming the wrong base multiple. 172.70.86.54 October 3, 2023 UTC. I agree with you on that best practice for sure. I don't feel qualified to determine which authority is most authoritative, though. Hoping someone with relevant industry credentials can make a qualified opinion. Azure Armageddon 1556, October 5, 2023 UTC.